Hello, good morning, all of you. Welcome again in the class of class 10 physics. Myself, Prakash I again welcome you. Now let's come on to the previous topic. In previous class, we were discussing about the refractive index of one medium. Refractive index was or is ratio between sine of angle of incidence to sine of angle of refraction. This is one way how to find refractive index. The meaning of mu12 means refractive index of medium 2 with respect to medium number 1. Let this is one surface. This is medium number 1, this is medium number 2. So let the light is coming from 1 to 2. The refractive index of medium number 2 with respect to medium number 1 will be equal to sine of angle of incidence at this point. This angle is formed I. This angle I to this angle R. So this is sine I upon sine R. This is not only the formula to find the refractive index. Refractive index can be calculated as mu12 equal to velocity of light in the medium number 1. Let the velocity of light is c upon velocity of light in medium number 2. This is b. This is one more way how to find refractive index. As we know, the velocity is always equal to frequency into wavelength. So let the frequency of light in medium number 1 is mu. So there is no change in frequency. Either this is medium 1 or medium number 2. And let the wavelength is lambda upon v. This is now mu into lambda. This is lambda 1 and lambda 2. So this is mu 1 2. Both mu are cancelled. So mu 1 2 equal to lambda 1 upon lambda 2 or lambda 2 equal to lambda 1 upon mu 1 2. One more way. Lambda 1 is equal to mu into mu 1 2 into lambda 2. So let the refractive index of medium number 2 is more than medium number 1, then wavelength will decrease. And let the refractive index of medium number 2 is less than medium number 1, then wavelength will increase. That is relationship between the wavelength and the refractive index of medium. This is one factor on which refractive index depends. This is not only the factor. There are some other factors on which the refractive index of medium depends. Generally, this question is asked in the 3 to 4 marks. What are the factors on which refractive index of one medium depends? Sometimes he asks the name of only factors. Sometimes he asks how the factors affect the wavelength. So let's see, or the refractive index. So let's come on the factors. Factors on which let's come on the factors on which the refractive index of one medium depends. Generally, this question is asked in exam. Factors on which refractive index depends and how. This is factor number 1. refractive index depends on wavelength. Factor number 1 on wavelength. When the wavelength increase, I am showing this arrow, showing upward direction. The wavelength increase, refractive index decrease. Inversely proportional. As we know, let the lambda 2 is more, then mu 1 2 will be less. The product is constant. Number 2, temperature. When temperature increase, again refractive index decrease. This is factor number 2. And factor number 3. Factor number 3 is optical density. When optical density D increase, then refractive index also increase. This is one factor which is directly proportional. So let the question is an exam. What are the factors on which the refractive index of medium depends? So that only 3 factors: wavelength of light, number 2 temperature, number 3 optical density. Let me ask you how the refractive index depends. Then you have to write the full statement. I have written in short for you. If the wavelength increase, refractive index decrease. If temperature increase, refractive index decrease. If optical density increase, in that case refractive index also increase. These are 3 factors on which the refractive index of one medium depends. Okay. Now come on the next point. Next point is reversibility. Sometimes we ask the principle of reversibility. Let this line is dividing the medium in 2 parts. This is medium number 1 and this is medium number 2. Let the density of medium number 2 is more than density of medium number 1. I am assuming this is not compulsory that the density of medium number 2 will be more than medium number 1. The density of medium number 2 may be less than medium number 1. I am taking a simple example. So let light is coming from medium number 1 at this point, incident ray. This is normal, ground at this point. If density of medium number 2 is more than density of medium number 1, so light will bend towards normal. Okay, this is the actual path of light. It will be the path of light. This is angle I and this is angle R. So angle I in this case 1. In this case 1, angle I is more than angle R. Let I am putting one mirror at this point in the front of this light ray, and this is forming angle of 90 degree. This is mirror. I hope you all can understand by simple this symbol mirror, and this is forming angle of 90 degree. When the light is coming on the surface of this mirror at the angle of 90 degree, in this case at this point, let's point is P. Yes, okay, now let's point is M. Mirror is M. Let's point is M. At M, angle I equal to 0. because angle of incidence is angle between normal and incident ray. So as per law of reflection, angle R also will be equal to 0. So the path through which light is coming on the surface, by the same way, on the same path light will go back. It means light will again come at this point and light will go back on the same path. Means this light is reversing back, but following its own rules, the law of reflection. Now let's come on the whole this experimental process. When light was coming from medium 1 to 2, case 1, when light was moving from medium number 1 to medium number 2. So refractive index of medium number 2 with respect to medium number 1 will be equal to sin I upon sin R. Now, when light is going back from path, this is case 2. Case 2, when light goes back. When light goes back. In the previous case, light was coming from medium number 1 to medium number 2. In the case 2, light is going from the medium number 2 to medium number 1. So in that case, in the case 2, angle of incidence will be angle R and angle of refraction will be angle I. So mu 2 1 means refractive index of medium 1 with respect to medium number 2 will be equal to sin R upon sin I. On multiplying both, this is number 1 and this is number 2. On multiplying by 1 and 2, from 1 and 2, mu 1 2 multiplied by mu 2 1 equal to sin I upon sin R multiplied by sin R upon sin I. The all are cancelled out, equal to 1. Okay, it means mu 1 2 into mu 2 1. Mu 1 2 multiplied by mu 2 1 equal to 1, or mu 1 2 equal to 1 upon mu 2 1. Means when the light was coming from the medium number 1 to medium number 2, the refractive index was mu 1 2. In that case, in the reverse case, the refractive index will be just opposite to previous one. This is called the principle of reversibility, and how we can find the relationship between these two refractive indices. Okay, let's come on the topic lateral displacement. To know the lateral displacement, we have to go through some experimental verification. Later, I am discussing about the one object that is called a glass slab. Means one object of the glass which is kept. Let its thickness is T. Thickness is T. Okay. And later, light is coming on the surface of the glass slab at this point, and this is normal, this is glass, and this is air. So again, refractive index of the glass, you can say this is mu A mu G, refractive index of glass with respect to air is more than 1. So light will bend towards normal. I will comment this point. Then again, when the light will go out from the mirror, so glass, then again light will go from denser to rare medium. Again I will tell you, when the light was coming from air to glass, light was coming from rare to denser medium, so angle I and this angle R, so angle R was less than angle I, because angle R is found in denser medium. Now light is going from glass to air again. This is again air. So it will go away from the normal. So this angle is again R. And this angle is E. This angle is at E. Angle of emergence. So the angle E is more than angle R. So this is actual path of light. But later there is no medium, light has to go straight on this path. The both paths will be parallel to each other. Actually, initially light had to go directly from this path, but light is going through this path. It means there is some displacement in between these two light rays. Displacement. This one. This is displacement. This is called lateral displacement. This is how the light behaves from the one medium to enter from one medium to another medium, and what are the factors on which the lateral displacement depend. So factors on which lateral displacement depend are: first one, angle of incidence. Number two, thickness, angle I, thickness of glass, T. Number three, refractive index of the medium, and number four, the wavelength of light. How the lateral displacement depend on the factors we will discuss in the next class, and this again very important point. 4 points, 4 marks for the board exam. I hope you have got the concept. Thank you. Have patience.